What's up, mobile devs? In this tutorial we will make from scratch the animation of a clock loader entirely in Reanimated 2. This animation is inspired by a dribble animation made by Oleg Frolov. I will put, of course, the link in the video description. So honestly, this type of animation can also be made using a Lottie file. But from my point of view, making it using Reanimated provides many more degrees of freedom in the customization phase. So if you love making React Native animations, don't forget to subscribe to my channel to stay updated on my upcoming videos. That said, we can finally get our hands dirty and we can finally start to code. So here we have a React Native project initialized with the Expo CLI and of course with the TypeScript configuration. In the package.json you can see that I've already installed just the Reanimated package. We are going to use a version above the 2.0. The 2.0 version, and don't forget to add the React Native Reanimated plugin inside the bubble config.js in order to complete the Reanimated installation process. So that said, we can start to update the background color. So let's use a black background color. Let's fix the status bar and let's get rid of this of the text. So here we are going to display 12 different squares, and in order to display these squares we are just going to fill a dummy array, and we are going to map this array with just accessing the index value. So here let's return a view, and this view right here will be our square. So of course we need to specify the key property, and we need to pass here the style. So each square will have a height equal to 12, a width equal to 12, so let's say aspect ratio equal to 1, a background color equal to white. And it is fine like that. So here we have 12 different squares. In order to visualize individually each square, let's actually update this opacity. So let's say opacity equal to index divided by 12, since we have 12 different squares. Here we can see just 11 squares, and that's because the first one will have index equal to 0. So in order to fix this behavior, let's just say index plus 1. And we can see here the first square. So here we have a lot of different constants. Let's try to refactor a little bit these constants inside a specific file. So let's define here the n constant, so the amount of squares, and let's define the square size that casually is equal to 12. So let's import here the n constant. Here it will be n, and here it will be the square size. So at this point everything is working nicely, but we need to refactor a little bit this component. So since we are going to do a lot of stuff with this component right here, let's create a components folder, and let's create a square tsx file. So here we are going to define a React Native functional component. And let's copy this code right here. So we need to access the square size, we need to access the n constant, and we need to access the index parameter. So let's define the square props. Let's specify here the index, and the square will be a React Native functional component, a React functional component actually, with these square props. So let's access here the index. So here we can import the square component that we have defined, and we need to pass the key equal to index, and the index, actually there is an issue, so we need to import, of course, and let's say index equal to index. And we are good to go. So here we have our 12 squares, but in order to, so we are going to animate individually each square, and in order to have much control over the individual square, it is better to define the position equal to absolute. So we are going to update later the rotation and the translation based on the position absolute. So for now, let's also fix right now the translation. So let's specify the translateY parameter, and the translateY will be equal to index multiplied by square size. So in order to avoid, in order to flip vertically these squares, let's just add the minus sign. And here we go. So right now we are going to animate the rotation and the translation, but let's start from the rotation. And let's start to see actually how it should be the final angle of each individual square. So basically, when the animation will be completed, each square will be positioned with the same distance. So the distance between each squares will be equal, will be identical. And this offset angle will be equal to 2 pi divided by n, since we have n squares and 2 pi is just the full rotation. So the final angle will be, of course, proportional to this offset. So let's say offset angle multiplied by index. So y multiplied by index. So actually this final angle isn't correct, but I want just to decide an angle based on the square index. So with this kind of statement, we are just defining a final angle that is proportional to the offset angle and proportional to this to the index. The final angle, of course, will be different for each individual square. So let's apply actually this rotation and let's see what will happen. So let's say final angle and radians. So here that's not what we are expecting. And that's because this transform array needs to prioritize the rotation first. So inside the transform array, of course, the order of each action is really important. So we need first to apply the rotation. So it seems actually that this angle is correct. But it isn't, since we want that this square right here, that is the last square, since the first one has the less opacity, we want that this square right here is on top, is right here. So we want that the rotation, the final angle of the last square, that will be the square n minus 1, has the final angle equal to 0. So in order to fix this behavior, we just need to say that n minus 1 minus index, so we just need to add n minus 1 minus index, since we want that if the index is equal to n minus 1, this final angle should be equal to 0. And we can see that everything is fine. So for now, we can actually start to animating this the rotation process, and in order to do it, let's define outside, inside the app component, a progress shared value, and let's animate inside a use effect hook from React this progress dot value. So we are going to use a with timing function in order to animate the progress until the value 2 pi. So in order to complete a full rotation. And let's specify here the duration equal to 4 seconds. So this progress, this shared value, this progress shared value needs to be passed inside this square. And we are going to access the progress shared value inside each square. So of course we need to define the shared value outside each square, otherwise we are going to create 12 different shared values. So let's, so here we need to specify for TypeScript the progress type. So progress will be an animated from a reanimated shared value of type number. And here let's access the progress. So for now we can animate. So let's define the reanimated style with use animated style. And let's return, let's just copy this transform operation right here, and let's paste inside the reanimated style. In order to animate this view, we need, of course, to use an animated view, and we can pass the reanimated style. So, of course, nothing is working, and that's because we need to pass here our shared value, let's say. And basically we want that for each square, the rotation is equal to the minimum between the final angle and the progress dot value. So the progress dot value will be animated from value 0 to value 2 pi. And if the progress value is less than the final angle, we must animate. Otherwise, we need to keep the current final angle. So we can say that rotate should be equal to the minimum between the final angle and the progress dot value. And we can pass here the rotate parameter. And we can see that everything is working smoothly. But so if you look closely, you can see that the animation is not linear, it is quadratic. And we need to fix here the easing. So by default, inside the with timing function, the easing will be quadratic. So let's import easing from Reanimated, and let's force it to be linear. So everything is working nicely. Of course, we need also to animate the translation. So we don't need just to animate the rotation, we need also to animate the translation. And the translate shared value will be based on this rotation, this rotation parameter. So in order to animate the translation, let's refactor a little bit this code. We just want to keep this rotate parameter outside this use animated style. But a code like that will not work, and it will not work since the since the rotate parameter needs to be recomputed every time that the progress.value changes. So in order to fix this behavior, we need to derive the rotate value based on the progress.value, and we can do that just by using the useDerived hook from React Native Reanimated. So of course, normally this statement will work, but since the progress.value is a shared value, we are forced to use the useDerived value hook. So let's return this statement, and let's say here rotate.value. So right now we can define the translateY, and we can derive the translateY based on the rotate derived value. So for now, let's just return this value right here. And let's say here translateY.value. So basically what do we want? We want that if the rotate value is equal to the final angle, so if the rotate animation is completed, we want that the translateY stretches until the radius amount. And the radius amount is basically equal to n multiplied by square size. So here let's add a minus just to be consistent with the previous translateY. And let's reload. So I believe it was glitched. And we can see that everything is working nicely. Let's just use here the withSpring high order function. And let's reload. So we can see that everything is working nicely. So of course here we are handling the first round, the first rotation. Let's handle the second rotation. So we are going to animate the progress.value until the value for pi. So if we reload, we can see that not everything is working at all. And we need to handle the second rotation manually. So let's start from the rotate derived value. So we know that this condition right here is perfect, but it is perfect when the progress.value is less than 2 pi. So let's say if progress.value is less than 2 pi, let's return this statement. Otherwise, let's return the progress.value. So let's see. And we can see that nothing is working. So the second rotation is not working at all. Basically, so in order to visualize better what's going on, let's extend the duration to 8 seconds and let's reload. So here we can see that we don't want instantly that the rotation is equal to progress.value, but we want that the rotation stays equal to the final angle until a specific condition. So we want that if the progress.value minus 2 pi is less than final angle, we want to return the final angle. So why this condition? Basically, we are just, we know that here this condition is true when progress.value is less than 2 pi. So here the progress.value will be greater than 2 pi, and we need just to decrease the progress.value in order to compare with the final angle. And here we know that the final angle, we want that if the progress.value here on the second round is less than final angle, we just want to keep the current final angle. So basically this condition is just almost identical to this one, but it's just the complementary condition. So let's reload. And we can see that everything is working almost nicely. So what is happening right here, and what do we, so the rotation animation is working nicely, but we need to fix this translateY animation. And what do we want to do? We know that at the beginning the translateY, actually let's visualize the squares. We know that at the beginning the last square is right here, and the first square is like right here. So if we run the animation, we can see that we want to flip the order of the squares. So we want that the last one become the first one, and vice versa. So as a friend of mine would say, we want that the first will be last and the last will be first. And in order to handle this kind of behavior, we just need to fix here the translateY amount if the progress.value is greater than 2 pi. So here we want to flip the order. So we want to flip this condition right here. And in order to flip, we just need, I believe, to specify here n minus index multiplied by square size. So, or index minus n. So let's reload, we are going to figure it out. So of course here we need index minus n. And let's see. And we can see that everything is working nicely. So here n minus index or index minus n is just to fix this sign that we have right here, so the orientation. So here, in order to smooth a little bit the animation, let's just use the with timing, and let's reload. And we can see in the end that the animation is working perfectly. So of course we want to repeat over and over this beautiful animation. And in order to do it, we are going to use another high order function that is called with repeat. So let's wrap this with timing with the with repeat high order function. And here let's specify that we want a number of repetition equal to -1. So -1 is equal to infinite. We want infinite repetitions. So let's reload. And let's see if everything is working nicely. So the first 2 rounds seems to work fine. But here, when the animation repeats for the second time and for the third time, we can see that there is a little glitch here. So we can fix this behavior by adding the with timing function. So in the end, we can also remove this opacity, since we have just used this opacity to improve the developer experience, but we don't need it in the final animation. So let's reload, and we can see the final result. So here we can see that everything is working perfectly. So I hope that this explanation was clear. Actually, I know that this tutorial seems hard, but it isn't that complex. So if you like this kind of content, if you like Reanimated as I like it, please subscribe to the channel or leave a comment in order to give some suggestion for future videos.